Today we are solving LeetCode 978 longest turbulent subarray. This is a medium problem, but the core idea is very simple if we understand comparison science properly. In this problem we will learn 5 important DSA concepts. First, how to compare adjacent elements in an array. Second, how to detect alternating patterns. Third, how to use a sliding window style thinking without explicitly maintaining a window. Fourth, how to reset the current answer when the pattern breaks. And fifth, how to solve the problem in ON time and open space. Let us understand the problem first. We are given an integer array ARR. We have to return the length of the longest turbulent subarray. Now the first question is, what does turbulent mean? A subarray is called turbulent if the comparison sign between adjacent elements keeps flipping. For example, ARR equals 4, 2, 10, 7, 8. Now compare adjacent elements. Now compare the adjacent elements. So you will see this is our array. Now this ARR1 is greater than ARR2. That is 9 is greater than 2. Sorry, 4. And then we see that 4 is less than greater than 2. So this portion is not a turbulent. But if we start with 4, 4 is greater than 2, then 2 is less than 10, then 10 is greater than 7, then 7 is less than 8. So this portion from 4 to 8, this is turbulent because signs are alternating. The pattern is greater than, less than, greater than, less than. This means the signs are flipping continuously. So this is a turbulent array. In simple words, turbulent means up, down, or down, up, down, up. So this is what turbulence means. Or it can be down, up, down, up. The comparison signs must alternate. Now look at the first example. This output is 5. 4 is greater than 2. Uh, 2 is less than 10. 10 is greater than 7. 7 less than 8. So this array, subarray 4, 2, 10, 7, 8 is turbulent. The signs are greater, less, greater, less. So the length is 5. Now let us look at example 2. In this, here all elements are increasing. 4 is less than 8, 8 is less than 12, and 12 is less than 16. The signs are not flipping. They are always less than. So the longest turbulent subarray can only have length 2. Why 2? Because any two unequal adjacent elements are always turbulent. For example, 4, 8 has only one comparison. So there is nothing to break. So output is 2. In example 3, this array is of single element, that is of 100. So a single element is also considered a valid subarray, so output is 1. Now let us discuss the brute force method. The brute force idea is simple. Try every subarray. For each subarray, check whether the comparison signs are alternating or not. For example, for every starting index I, we try to extend the ending index j. At every step, we compare a double r j minus 1 and a double r j. So idea is very simple. We try every subarray and we compare. We start with index starting for every starting index I. We try to extend the index j, and we check if a double r j, the comparison between a double r j and minus 1 and a double r j. Then we check whether the current comparison sign is opposite to the previous comparison sign or not. If yes, the subarray is still turbulent. If not, we stop. This method works, but it can take order of n square time in the worst case. So time in worst case is O of n square. So we need an optimal approach. Now let us move to the optimal approach. The important observation is this: we do not need to generate all subarrays. We only need to track the current turbulent length while scanning the array once. At every index I, so we only need to track. This is the main observation, that we do not need to generate all subarrays. We just need to track the current turbulent length while scanning the array once. At every index I, we compare a double r I minus 1 and a double r I. So at every index I, we compare a double r I and a double r I minus 1. There can be three cases. Three cases are there. First case is a double r I minus 1 is less than a double r I. Second case is a double r I minus 1 is greater than a double r I. And third is the equal case. So for the first case means the current sign is positive or increasing. For the second case, it means the current sign is negative or decreasing. And for third case, the current sign is 0. If the sign is 0, the turbulence breaks completely. For example, in case of 8,8. So here turbulence breaks completely. And in case of same sign, and in this case, the current turbulence length will become current turbulence length equals 1 now. Now suppose the previous sign and current sign are opposite. For example, previous sign equals greater and current sign equals less. Then turbulence continues. So we increase the current length by 1. But if the previous sign and current sign are the same, then the turbulence breaks. For example, 4, 8 and 12. So 4 is less than 8, less than 12. So previous sign equals less than. Current sign equals less than. Not equal, like this. So current turbulence length will become 2. Here the signs are less, they are not alternating. But the current pair 8,12 is still a valid turbulent subarray of length 2. So when the pattern breaks but the current pair is unequal, we reset current length to 2. This is the most important part. If current sign is 0, reset length to 1. If signs alternate, increase length by 1, otherwise reset to 2. So this is the logic that we need to follow while comparison. Now let us write the pseudocode. Start with answer equal to 1, current length equal to 1 and previous sign equal to 0. Now loop from index 1 to n minus 1. Compare a double r I minus 1 and a double r I. If a double r I minus 1 is less than a double r I, then the current sign is 1. If the previous element is greater than the current element, then current sign becomes minus 1. Otherwise, current sign is 0. Now let's check if current sign. So these are 3 cases. Now if current sign is 0, current length equals 1. Else if previous sign and current sign are opposite, then current length equals current length plus 1. That is, we continue the subarray. And else we don't continue the subarray. We reset the current length to 2. Update answer with maximum of answer and current length. Finally, set previous sign equals current sign and return the answer. Now let us write the Python code. So we initialize. First of all, we check the base case. If n double equals 1, then we simply return 1. There is nothing to check that at that time. Then we initialize our answer, current length, and previous sign. Now for I in range 1 to n, we start the loop. Compare the array I minus 1 and array I. We have 3 cases. First is less than. Then we update current sign equals 1. And if it is greater than, that is the previous element is greater than the current element, then we update current sign equals minus 1. Else, when they are equal, we update current sign equals 0. Now we check the value of current sign. If current sign equals 0, then we make curl equals 1. Else if, this will be not if but else. Curl sign previous sign multiplied by curl sign equals minus 1. That is, the signs are opposite. Then curl will be increased by 1. So plus equals 1. Else, that means both the signs are same. We reset it to 2. Because the current array will be the valid one, the one with single sign. Array of subarray of 2 elements, and they are not equal. Then we finally update our answer. And set our previous sign equals current sign. Then after exiting the loop, we return the answer. Now let us dry run this code on the first example. Let's dry run. So initially answer equals 1, curl n equals 1 and previous sign equals 0. Then at I equals 1, we compare ARR0 and ARR1. ARR0 is greater than ARR1. So we update our cur sign. So cur sign equals -1. And our previous our cur length becomes 2. Cur length equals 2. See how carefully we wrote this logic. If cur sign equals 0, that is not 0, and previous sign into cur sign is equal to 0. So this else takes care of both the cases. If we had written equals +1, then equals 0 case would not be handled. So we have successfully handled this case also when previous sign is equal to 0, but my current sign is something non-zero. So in that case, current length will be 2. And if previous sign is same as the current sign, then also current length will be 2. Now this previous sign becomes -1. Now at I equals 2, my array 1, ARR1 is greater than ARR2. So cur sign becomes -1. And now again it will go to the else condition and cur length will become 2 because cur sign multiplied by previous sign, that is equal to 1. So the else case, previous sign multiplied cur sign is equal to 1. This is not true, this is not true. So it will go to else case. And finally previous sign will become equal to -1. Now at I equals 3, my cur sign will this ARR3, that is 10, is greater than ARR2. Or we compare in the opposite direction. So ARR2 is less than ARR3. So this time it will become, cur sign will become equal to 1. Cur length will become, what was our previous cur length? That was equal to 2. So it will become 2 plus 1 equals 3. And now we set our previous sign equals cur sign, that is equal to 1. Now at I equals 4. So ARR3 is 10 is greater than 7. So cur sign will become -1. Cur length will become 3 plus 1 equals 4 because previous sign was 1 and cur sign was -1. So multiplication is -1. So its length will increase. Now previous sign will be updated to minus 1. Now at I equals 5. So this time 7 is less than 8. So curve sign will become 1. Curve length will increase by 1 length. So 4 plus 1 equals 5. And previous sign will be updated, that is equal to 1. Now at I equals 6. So this time ARR5 is equal to ARR6. So curve sign will become 0. Curve length will become 1 and previous sign will become 0. Also we are updating answer at each other cases. So at I equal to 1, our answer will become max of curve length and answer. So answer will become max of curve length and answer, that is 2. At I equal to 2, answer will become 2. At I equal to 3, answer will become 3. At I equal to 4, answer will become 4. At I equal to 5, answer will become 5. At I equal to 6, answer will remain as 5. Now at I equals 7. So this time 8 is greater than 1. Curve sign will become equals minus 1. Curve length will become equals 2 this time because it will go to the else case. And previous sign will become equals minus 1. Answer will remain as 5. At I equals 8. So 1 is less than 9. So curve sign becomes equal to 1. Curve length will increase by 1, 2 plus 1 equals 3. Previous sign will now be updated to 1 and answer will remain as 5. Now I goes from range 1 to n, and n was our length of the array that we had received. So I think we need to write n equal to len array. Len array is our for this 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 elements are there. So len array is 9. So I will run from 1 to 8. So at this index I equal to 8 it ends. Now it will not go further. So this was our dry run. Finally the answer is 5. Now let us talk about time complexity. So time is equal to O n because it only we are scanning the array only once. We are not using any extra array. Because we are scanning the array only once, so time complexity is On. And also we are not using any extra array. We are only using a few variables like answer, current line, previous line, and cosine. So space complexity is O1. Now let us run this code. We need to uncomment this first. Comment this out. Let us run. Okay. Let us submit it now. Okay, so all the test cases passed. Finally, let us discuss the critical mistakes. So mistake number 1 is do not include equal adjacent elements in a turbulent subarray. For example, 8, 8, this is not turbulent because there is no less than or greater than sign. Whenever ARR minus 1 double equal to ARR, reset current length to 1. Second mistake is when the sign does not alternate. Do not reset the current current length to 1. Reset it to 2 if the current pair is unequal. For example, 4, 8, 12. At 4 less than 8, current length is 2. At 8 less than 12, the sign is repeated. So the previous turbulence breaks. But 8, 12 is still valid. So current length should not become 2. Should become 2, not 1. Third mistake is don't confuse index parity with actual comparison signs. The problem statement explains turbulence using odd and even indices. But in implementation, we do not need to depend on odd and even positions. We only need to check whether adjacent comparison signs are alternating. Fourth mistake is always handle the single element array. If A double R double equal to a single element, that is 100, answer should be 1. Now let us conclude. In this problem, the main idea is to observe the signs between adjacent elements. If the sign flips, the turbulent subarray continues. If the sign becomes equal, reset to 1. If the sign repeats but elements are unequal, reset to 2. This gives us a clean ON solution with O1 space. So the final answer for the first example is 5 because 4 is greater than 2, less than 10, greater than 7, less than 8. Has length 5. That is a complete solution for LeetCode 978 longest turbulent subarray.